So hello all. In the previous lectures, we were learning about class of organic compounds called as alkane, alkene, and alkyne. We knew what are the general formula of alkane, alkyne, and alkane, alkene, and alkyne. And we also came across how to write the formula from their general formula. Now, continuing further, we will deal with cyclic hydrocarbons. Cyclic hydrocarbons. What are hydrocarbons? The compounds of carbon and hydrogen only are called as hydrocarbons. When they are arranged in a straight line or straight chain fashion, they were called as straight chain alkane, alkene, and alkyne. When they are arranged in a cyclic manner, like if I am saying 6 carbon atoms were arranged in a chain, right? 1, 2, 3, 5, 6. They arranged in a chain fashion. Now, if I bend these and make them a ring, they can be arranged like this also in a cyclic manner. So, these cyclic or closed chain arrangement of hydrocarbons are basically called as cyclic hydrocarbons. And an interesting thing to note here is these cyclic hydrocarbons have the same general formula like that of alkene. Alkene was having general formula CnH2n, but these cyclic hydrocarbons, although they fall into the category of alkane because all are having single bond, right? But what happens? There was presence of double bond between the same carbon atom, but here this carbon atom is forming one bond with this carbon and one bond with this carbon. So for each atom or for each carbon atom, two of its valencies are satisfied in bonding with two other same carbon atoms. That's why the number of hydrogen will be reduced. Here it has two hydrogen occupying tendency. The same goes for this also, and even here they have the tendency of occupying two hydrogen, right? So by default what happens, their general formula comes down to the general formula of alkene, although they are single bond forming compounds called as alkanes. Okay, so this was it about cyclic hydrocarbon. Next we will deal into the most important part of this chapter, that is nomenclature. Okay. Nomenclature. What do you mean by nomenclature? First of all, nomenclature means naming of compounds. Naming of compounds. Like when a child is born, the first thing we do is give a name to that person. Like how do we identify that person? With this particular name, I am having a name, you all are having a name, and people know us by that name only. So basically, when an organic compound is born, it is also given a name, and the process of naming is nomenclature. And sadly, naming us is also not called nomenclature, but naming an organic compound is called nomenclature. Now, how do we name? Basically, if we consider us, we are having two sets of name commonly. One is our nickname and other known as the school name, or like with what name our friends, our teachers know us. And the nickname is the name which usually our parents and our close one call us, right? So even organic compound is also the dear organic compound of its parents, and it is also having a nickname as well as a good name or official name. Okay, so the official name of organic compounds are given by a organization which we call IUPAC. IUPAC, which stands for International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. So this particular organization called as IUPAC is entitled or authorized to give the official name whenever an organic compound is being discovered or born. Okay. Now, that particular organic compound has a name given by IUPAC. It also has a common name with which it is commonly known as. So therefore, organic compound has two sets of name. One is the IUPAC name or the IUPAC form of nomenclature. Another one is the common name. It has two sets of name. One is the IUPAC name and the common name. What is interest to us is this IUPAC name. Okay, this is the universally accepted name. Wherever you go, if you know a compound by its IUPAC name, that will be universally recognized. And for naming any organic compounds, IUPAC has set or made a set of rules which we have to follow in order to name a compound. We all have the authority to name a compound, but the rules are set by IUPAC and those rules are hard and fast. We cannot deviate those rules. So first of all, we will consider our parent class of compound alkane, and we will take straight chain alkane and see how straight chain alkanes are named. So before going into the name, we have to remember certain prefixes. The first thing is, if an alkane is having one carbon atom, that is given a word root. Okay, we have to know the word root associated or which is derived basically from the number of carbon atom. If an atom is having, or if an organic compound is having one carbon atom, that is given a word root meth. M-E-T-H, meth. If an organic compound is having two carbon atom, it is given the name eth. Similarly, 3 carbon atom, prop. 4 carbon atom, but. 5 carbon atom, pent. 6 carbon atom, hex. 7 carbon atom, hept. 8 carbon atom, oct. 9 carbon atom, 10 carbon atom, tech. These are the word roots associated with the organic compound having these particular number of carbon atoms. So you have to remember these word root. These word roots are highly important. The next rule is, basically for naming straight chain, we have to go through only two rules. The first is you have to remember the word root. Second, if it is having all single bonded carbon atoms, like if it is an alkane, it has to follow by a suffix. If it's an alkane, it has to follow by a suffix ane. If it is an alkene, it has to follow a suffix ene. If it is alkyne, it has to follow a suffix yne. These are the suffix which follows our word root, and if we combine the suffix as well as the word root, we'll basically count the number of carbon atoms. We will combine the suffix and the word root, we will get our name of the organic compound at hand. For example, let us start with a simpler one. I am saying CH4. How many carbon atoms are there? Obviously 1. It is evident. So the word root is meth. And it is only and only formed by single bonds. Therefore, methane. Now if I see 2 carbon atoms bonded, CH3, CH3, it forms or it gets the word root eth. And obviously single bond, that's why ethane. And it follows as, if 3 carbon atom, it will be propane. Hydrogen doesn't matter, right? Hydrogen obviously by default you have to fill. If you satisfy the number of, like if you form the skeleton, then you just need to satisfy the valency of carbon by giving it the required number of hydrogen atom. Butane, pentane, likewise it follows. Okay, how question come? Usually if you are given CH3, CH2, 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 CH3, and you are asked to name this compound. How you will name? First of all, you will simply count the number of carbon atoms here. How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms and all are singly bonded. So the word root for 7 carbon atom is hept, as singly bonded ane, heptane. Okay. So this is how, it is pretty simple, right? So this is how straight chain hydrocarbons are named. Now if I see a double bond. Okay. So when these type of cases arise, in the previous case what you were doing? You were starting the numbering from this side or from this side, doesn't matter. Counting the number of carbon atoms. Whichever side you chose, that was fair and it was correct. But in case of alkene and alkyne, wherever you see a double bond, you have to give that carbon the lowest number. That is called the lowest locant rule. Lowest locant rule. That particular bond has to be given the minimum number. So if I start my naming from this side, 1, 2, 3, 4, 5, 6. So this bond is getting 5th position, right? If I'm going from this side. If I'm going from the opposite side, 1, 2, 3, 4, 5, 6. In this case, this is getting the first site. Okay. So obviously, I'll follow my naming from this side. Now I'm having 6 carbon atoms here. So the word root that follows will be hex. But will it be ane? No, because I'm having a double bond right here. So the name will be hexene. Okay. The compound I'm having, if you see the name, you are seeing ene. That means obviously the compound is having a double bond in its structure. Now, if suppose the double bond, instead of being here, I'm placing the double bond right here. Again, I have 2 sides of naming. One is 1, 2, 3, 4, 5, 6. From this side, the next is 1, 2, 3, 4, 5, 6. Obviously, in this place, the carbon is getting, or the doubly bonded carbon is getting the word place of 2, and here it is getting 5 from this side. So obviously, the feasible side will be this one. Now, if I'm following this side, then the word root that follows here is, I'm having 6 carbon atoms, so hex. Now, shall I simply place ene because of the presence of double bond? No. If the double bond is present anywhere other than the first position, I have to mention the position in which the double bond is present. Because basically by seeing the name of the organic compound, you should be able to give the entire idea about the exact structure. So if I'm saying my double bond here is present at the second side, right? So I will be saying it is followed by a hyphen, 2 ene. This is basically the way of writing this particular alkene. If I'm looking simply at this, I'm not having this one in front of me. I'm simply looking at this. I will say I am having a 6 chain or 6 carbon long chain of organic compound, which is an doubly bonded organic compound, a set class of alkene. And here the double bond is present on the second site. Okay. This information I can draw simply by looking at this structure or this name. Okay. Now, if I see another example. Okay. So if I'm giving you the formula structure again. Okay. If I start naming from this side, it will be 1, 2, 3, 4, 5, 6, 7. From here, 1, 2, 3, 4, 5, 6, 7. So here I'm getting the position of 5 for this carbon and 3 from this side. So obviously I will start from this side because here I'm getting the lowest number for my double bond. So the word root here comes out to be 7 carbon atoms are there. So the word root is hept. And where is my double bond present? On the third side, right? So I will write hyphen 3 hyphen, and the double bond is, suppose let me make it Y, triple. So the bond will be YNE. The suffix for that will be hept 3 wine is the name. Okay. If I'm looking simply at this, I will say I am having an organic compound having 7 carbon atoms. Okay, I am having an organic compound having 7 carbon atoms, which is a alkyne. Here the triple bond is present in the third site. Okay, simply by looking at the structure, I will be able to say or draw the organic compounds. Here you are coming from the structure to the name. You can also go back like backwards. The name will be given to you and you will be asked to draw the structure. That also follows the same set of rules only. That is pretty easy, right? If you know this, like how to name from the structure, obviously the reverse will be very easy for you. Now, if I see branch chain, this was all about straight chain compounds. If I see branch chain, what happens? Suppose I'm giving you carbon, carbon. Okay, this set, I'm ignoring hydrogen because hydrogen by default is there. I'm simply looking at the carbon skeleton. So here in the previous, it was straight chain. What we had to do is simply name the number of carbon atoms arbitrarily from this side or that side, depending upon the lowest locant rule to the double bond. Here the same will be followed for this. These are particularly called as branches. Okay, these are called as branches. And the rule is pretty much same as that of double and triple bond. What you have to do here, again you have to follow the lowest locant rule. Where you have to give the lowest number to these branches. Okay, so if I'm naming from this side, and again most important thing is I will have to choose the longest carbon chain. The first thing I have to look for is select the longest carbon chain. Select the longest carbon chain. This is the first thing I will do. The second will be to go for the lowest locant rule. Okay, so if I'm naming, I'm starting the naming of these organic compounds. I'm first naming this chain. Okay, 1, 2, 3, 4, 5, 6. If I'm going straight, I'm getting 6 carbon atoms. If I'm going like this, 1, 2, 3, 4, 5, 6, I'm getting the same number. If I'm going from this chain, 1, 2, 3, 4, 5, here I'm getting 5 carbon, 1 carbon less. So obviously I have to choose the longest chain. Either I can go from, or I can go with the straight one, or I can take this one as the longest chain. Okay, so consider I'm taking this one. Now here I have to follow the lowest locant rule. That means the minimum number must be given to these branches, right? I have to follow the lowest locant rule where I have to give minimum number to these branches. Now here, if you see in the first case, if I'm numbering from this side, then I'm getting my branching at second position and third position. So the first set of branching is 2 and 3. If I'll be coming from this side, that's also another possibility. So if I'm naming from this side, it is pretty evident that obviously this is after the third carbon, this will be the fourth carbon, right? So the first set of locant I will be getting is at a fourth position and next is at a fifth position. So obviously I will go with the 2-3 combination. So this will be my order of naming. So sorry for this. This will be my order of naming and I will go this way. So how many carbon atoms are there? 6 carbon atoms. That's why the name Higgs. Okay, and all are alkane, so Higgs, A-N-E. No need of giving the hyphen. Hexane. But what will happen to these branches? They will come to the prefix side. Okay, so the first branching I was having at second position, the next branching I was having at the third position. So, and both were of a single carbon. So, single carbon means the word root is meth, and as they are, if I simply look at them, this will be CH3 and this will be CH3. So, CH3 is a alkyl group, right? and the word root for them is meth, that alkyl will be methyl. So the name here will be 2,3 dimethyl hexane. The IUPAC name for this compound will be 2,3 dimethyl hexane. So in this video we have learned certain rules for nomenclature. We will carry on our the process of naming compounds from this like branch chains only. In our later videos we will see like a lot of examples. We will deal with lot of examples so that we get this concept clear. So that's all for this video. I hope you understood. Thank you.